All right. Uh, okay, welcome to the third episode for Machine Learning for Beginners webinar series. And today we have with us Shashank Bhushan, who is a software engineer at Google who works on machine learning products and other projects at Google. And so I'll just quickly introduce whosoever is on the screen as of now. I'm Jay. I am a research assistant at Arizona State University doing my grad studies in artificial intelligence. Omkar, would you like to go?
Hi, I'm doing my master's at NYU in computer science, and my focus is in computer vision. Yeah, Shashank.
Shashank, yeah.
Hey guys, Shashank Bhushan here. I work at Google as a software engineer. My main focus is working in machine learning, especially in perception. So my team and we build machine learning models, especially like deep learning models, to predict, to extract information from, or rather signals from images. So I don't know if anyone over here is quite familiar with it, but if you know about street view images, so my team specifically deals with that. We extract information from street view images, which then slowly makes its way to the Google Maps stuff.
Okay, okay. So is the work related to computer vision and perception basically at
Yeah, that's all about it.
right, right. Okay. So what would you describe as your first exposure to the domain of machine learning within after your academics, and what was your first exposure to the any kind of machine learning project? Because your like you have a good work experience prior to you joined over here as grad student at ASU. You have a good experience of machine learning projects at eCrypt and data science work over there. So what was the first outburst for you for the industry domain?
Sure, but just to get something out of the way, like it's a policy to say that any views of my presented here is my own and not that of, like I'm not presenting Google's view over here.
Yeah, definitely.
With that out of the way, so eCrypt is like, yeah, I got a lot of my experience at eCrypt, but eCrypt was not like before ASU; it was like during ASU's time. So just to give you a timeline, so
Okay.
after I finished my undergrad, I did about a year and a half of work in India, in Hyderabad. That was for like a consultancy sort of firm. So over there, the only exposure to machine learning that I would say I got was working with some sort of chatbots and also doing some sort of like big data processing stuff. Pretty minimal, not a lot. Then I started my master's, and yeah, about a year into my master's, I got a job at eCrypt, which I then continued like on and off throughout the year. Throughout the last year of my master's, I worked at eCrypt, and then I got into Google.
Okay.
So coming back to the questions, like how did I get into all of this? So from my second years in my undergrad, I had like a sort of fascination for image processing in general. That time it was not like you were not doing any kind of like deep learning or neural network stuff. The things that would at least taught, like I started out, so I was just reading out on the existing literature and stuff. So that was all about like SIFT, SIRFs, those sort of features, and how do you build edge detector models and stuff like that. From that, it slowly grew into a bit of NLP stuff. I remember I took a course under Prasenjit Majumdar for doing information retrieval. It was quite good. We did actually a lot of basic stuff that I know about NLP comes from that course, and we also did a pretty nice project in that course as part of that course. And after that, it was not so much like I kept up doing NLP stuff for like this chatbot that I said that I did at my first year at my work that I did in India. Apart from that, I would really say it all really started in earnest when I did started my master's.
Right.
So when I came here, when I came at ASU, I started like I took up courses, and I also started doing a lot more like like the online courses that you have available. I started doing a lot of those, and also took part in like Kaggle competitions. I didn't do really that well, but I guess it was all about like how much you could learn and how much uh, content you could put out there as well. Like Kaggle, also you could also do like data analysis stuff and like that. So I did a lot of those and took part in a couple of competitions. And yeah, and that's how and doing and you know and that's what the people at eCrypt saw, like me doing stuff at Kaggle, and that's how they contacted me to offer an internship for summer 2017.
Right.
Hmm.
Right. So like it seems like you have tried your hands on every possible aspect of computer science domain, starting from big data to data science, computer vision, NLP, and
Uh,
sorry, was I cut off?
yeah,
Yeah.
now you're fine.
Oh, okay. So like it seems like, as I was saying, it seems like you tried your hands on every possible aspect of computer science, like starting from computer vision, big data, data science, and now
Mhm.
again at computer vision at Google. Uh, Yeah. So, how would you describe your common workspace? And what kind of projects do you work on at Google? And what are the work approaches? What are the tools and technologies do you use over there?
So I would say it is. I would say this is common across the industry. So the major problem, at least when you're trying to put these kind of stuff like recognition or whatever into production systems, is data. Like when you're building new models, you have to be sure that the data that you're trying to use to train these models are like has the right composition. It's not really like easy for me to like describe, but if like a pretty no, I probably should not give that example, but it's like you have to ensure the data is right and you have the distributions right. Otherwise, you will mess it up.
Yeah.
So
So
you're more talking on the lines of data pre-processing.
you could say it's data pre-processing, but it's more. It's not about you like it's not only like it is about data pre-processing, but it's not only about like you adding in missing values or you doing some sort of um, let's say data massaging to kind of ensure you have the right data. It's also about like to me one thing that like pops out when I started like at least working for Google is you need to be pretty careful about the data distribution. Otherwise you would have really good metrics, but you would be underperforming at some really key points. And because Google works at a really huge scale, even if you're underperforming at some smaller areas, it is still a huge problem that you need to fix.
So I would say like
So
it's like understanding the metadata for the given data and preparing it for your analysis. Is it?
yeah, like one like quick example I could give is, let's say you're building a model for like detecting dogs, for example, and let's say you just have 100 breeds of dogs. Okay. And you're given this data and you're just like collecting samples and you send it to, let's say, operators or humans to just say, each image dog or not dog, right?
Yeah.
They could do that, but what could have happened here is that you have some breeds of dogs that are like over imaged. So you have way more examples of those dogs and very few examples of some other breeds of dogs.
So this is like an example of class imbalance.
So yes, it is. That's what I kind of mean by composition. You have to be pretty sure about the composition. So you get it right. If you have way more images of one kind of dogs, your model would do good. And because you have more images of those kind of dogs, your metrics would also be higher. Your precision recall would be higher.
Hmm.
But but in reality, you might be underperforming on some breeds of dogs.
Hmm.
So
Right.
that's kind of the major challenge. Like that's where the data issues comes in, and that's where I guess people spend most of the time in figuring out what data distribution went wrong and how to then remix your training and test data sets, not test data sets, but rather your trained data sets, so to have better performances.
Hmm.
Yeah.
Right. So like as you mentioned, like there are a lot of stuff like at least things like this, the pre-processing or working with the data before generating the models for that. What are the key differences of what did you find to be a hurdle when you jumped into the professional domain, and
Mhm.
things that were not taught into the academia or universities? Is there a major difference to be learned over there? Is the academia much more accepting of the what industry demands, or what are the things that you find as a key distinguishing features?
So the way I kind of see it is there are two, like I said, if you're trying to push things into production, you have to be sure it scales. One, and whatever things you're using, you have to scale, and you also have to ensure that it works across, a lot of different modalities of data or a lot of different variations of data. While in academia, you usually have I would not say a fixed data set, but you usually have a data set that is good enough, that is clean enough, or for which there are certain limitations, but those limitations are sort of usually listed out by the people who put that data set in place at the first hand.
Mhm.
It's much cleaner. And apart from that, I would say in industry, you don't iterate that much on stuff like hyperparameters. Like if you're, let's say a pretty simple like random forest model. I hope you
Yes, yes,
Yes, so it's a pretty simple model. If you're building it, you won't that iterate that much on the hyperparameters of the random forest model. What
right.
you would rather iterate on is ensuring that whatever features you have, they have the right distribution. While in academia, I guess it's the more of the opposite way, that you try to get that 1 or 2% you know higher input out above the benchmark.
Yes,
You would like to beat the benchmark on the data set. And the
yeah,
same happens with any sort of competition that you do online. You want to beat the benchmark rather than making things more scalable. So that's the major challenge.
so
The only difference that I feel is data. That's the only thing. Like when I first started my job at eCrypt, the challenge was not to build the first model. Like we had the first model. The challenge was about to improve it, and what we saw, like what I saw, is not that improvement did not come from me fixing some hyperparameters. It came from me understanding the data that they had and trying to ask more questions on how to better clarify so that the training set that we are creating is much more better representative of their actual data. So I
right.
guess that's where, and that's not something you could actually even teach people, like how do you clean data out.
Hmm.
Yeah.
Yeah.
And so, like as you mentioned in one of the previous answers, that you started you started pursuing your interest in the domain of machine learning by in your second year of undergrad, and
Mhm.
that's a very initial step from you. But for people who want to get started into the domain of machine learning, and you might have resorted to some kind of resources, blogs, and as you mentioned, Kaggle competitions.
Mhm.
What are some other resources people should look forward into, in your personal opinion? What are the other resources they should be trying? Some kind of best practices, say they should follow some online courses, or is it Kaggle competitions, or is it blogs, resources, Stack Overflow? What exactly is, according to you, a good way to start their career efficiently so that they don't get lost totally within this humongous network of machine learning resources?
Yeah, again, on that, it kind of depends from person to person. Like I had my roommate, he preferred like working with a professor, and and with a smaller, like the team that professor had, and they telling him what to kind of the papers to read, and that's helpful as well. Like when you're starting out, let's say in machine learning, you want to do, let's say, perception, you cannot just start, okay, I will read the first paper in perception and then come to it. That's not possible. It's always good to let's say have a smaller community. If you could get to that, to so that the amount of you could do a more focused reading. Other than that, I would say you could just start with getting your basics right. From basics, I mean, like it's a personal opinion again.
Yeah,
Like you should not jump into directly into, let's say, deep learning stuff. Have your basics clear on like what machine learning is. Like have your linear algebra cleared up. uh, you should take more courses in probability to understand how like probability works and how it is applied over here, and linear algebra, so that you could actually implement this stuff. And once you have these basics cleared,
Hmm.
probably then a good thing to do would be to start analyzing data sets. And like the way I did is, like, I just analyzed data set, I put it out there in Kaggle, I received feedback, I read other people's analysis to see what I was missing or what more could be done in the data set. The same went with Kaggle competitions. They have online like public kernels where you could just see what people just publish what they did. And
right.
looking at that, you could just understand, okay, this is something probably I could read on. And that's how I did. Like I read something, I saw something that people using something, a new sort of a neuron that I didn't knew, and then I read about it and try to then understand why it makes sense and things like that. So yeah, it can again. I think my answer is coming out like it sort of depends, but yeah,
Yes,
it
yes,
does depend what suits you.
yes,
Um, if you want into, if you let's say if you have time and you're just like you think you have time to build it up, I would say take your time, just get your basics correct, just get your math, stats, and linear algebra stuff cleared out, and then start venturing it into. Uh, it would be much easier to go that way. That route. That's all.
Okay.
right.
Could you please expand on the online courses which you did? Just to.
So I did. There is. Should I forgetting its name? There is one from Stanford on. Not Stan. Yeah, it's not the Andrew Next course. It's something else that I did. Sorry, I forget its name. It's. I think it's called Intro to Machine Learning or something. Apart from that, Andres Karpathy's
Hmm.
you know uh,
Computer vision course?
computer vision course. Yeah,
Yes, 231.
yeah, that's something I did. Apart from it, yeah, there are tons of online courses where you could find stuff, and there are tons of blogs as well, which are really great, which
Hmm.
deal all this stuff. And I guess if you do a Google search on like a reading list for deep learning, there are tons of Git repositories with archive links to where you could find the paper stuff. So
Right,
that's also cool.
Yeah.
right. And so you did your I guess masters just after you graduated from DA, I guess in 2015. So
Mhm.
what was the reason? Like we get a lot of questions, and also there was a confusion. There are a lot of confusions between the undergrad and masters part. They try to consider should I do a masters, or for the masters people should I do a PhD in order to get into the research of machine learning.
Mhm.
What are your views of, say, if I want to end up doing machine learning projects in some part of the industry, what are the industry demands? Like, is there a specific need that you need to have a master's degree, or do you need to have a PhD degree, and what are the different things that, say, embark on you if you have those degrees? What are the pros and cons of those degrees?
So PhDs, so if you have a PhD degree, it is you have a better chance of getting into machine learning. But that's not to say that if you don't have it, you don't have a chance. So in my current team, majority of the people are PhDs, but we have two people who have done their bachelors, but I would still discount them because they have way more industry experience. Um, um, but yeah, like masters is a good step. Like it's a good stepping stone, I would say. You should, um, and I cannot again I cannot say this about all the companies, but at least for Google, the interviews that I at least went through were about software development, except for my last interview where there were more questions around the projects I did and about machine learning and stuff.
All right.
So I would say it matters, but it doesn't matter so much. Like unless you want to get into the research side of machine, like the actual research side at these company, I don't really think it matters. If you're in applied machine learning, that's still masters or even a bachelor's would still be fine.
Right. Yeah. So like as you mentioned, like a lot of people within your team are PhD candidates and they have industry experience. And compared to those, you might like I might safely say that you have a bit of less experience in terms of, say, academy and industry. So what, according to you, would you say like that made you stood out among those candidates to be working at the same space? And so, like, is it something, yeah, like the projects that you did, or was it something like your academics was so good, or what exactly would you say that made you stand out equal to those candidates at Google?
I wouldn't say there is anything that I would say it just might be luck. Is that what I would say? Because like once like at least in Google, like once you clear up your interviews and stuff, they ask you for like your preferences. So you have to give out preferences on which field you want to work. So I gave machine learning as my topmost preference. So
Okay.
that's why I guess that's why they matched me up with teams which do work on machine learning. So that I guess that's about it.
Right, right, right. And yeah, Omkar, you were saying
Uh,
something? Yeah.
yeah. How is your experience at Google in terms of like the tools which you use with like the platforms which you use as compared to what we use in our projects, like in like say for example deep learning platforms or uh, languages or frameworks which you use.
Mhm.
Could you just elaborate on that?
So yeah, it's way more advanced in at least in terms of amount of compute power that I have and amount of storage and stuff like that, and the overall general support for like training, visualizing the results, seeing how the model is training and stuff like that. It's pretty much advanced, but I would still say if you could set up your own cluster, and the at least the basic package I would say is still like exported with TensorFlow that we use to kind of visualize our model training. But yeah, you have greater access to a huge amount of compute power that I didn't like. At least even in my startup, we didn't have that amount of computer storage power available to us. So like even your experiments you could do pretty big experiments
Mhm.
pretty quickly.
Okay. And another question is, what was something, what stood out in your profile which got you a call from Google for an interview? Because we are also currently like applying for internships and we'll be applying for jobs later on. So one thing which we are finding difficult is because we don't have work experience, we are facing difficulty in getting calls, like getting an interview in the first place. So could you give some advice on that?
So that's something like even I faced. So um, that I guess something is general across the hiring market in the United States that you need experience. It's kind of a catch-22 situation. You need experience, but to get experience, you need to works like a catch-22. So you cannot
Yeah,
have.
the deadlock.
So
Yes.
yeah, so yeah, that's there. I don't really have any good advice apart from just try to networking is one thing I did find. I did find like it does work. Like other people that I've seen, networking does work. At
Networking
least
as in, is it like contacting recruiters or like being in touch?
so. Yeah, not contacting like let's say other people who work in the industry, and you could just ask them, "Hey, give me a referral." At least in the bigger companies, it should not be an issue if you're asking them someone for a referral because yeah, it doesn't really matter. Like if I'm referring someone at Google, if that person doesn't get through, it's not a big deal,
Yeah.
right? So it's usually does not matter. People are pretty much open to helping other people out.
Hmm.
So probably that is something you could do. Other than that, yeah, building a profile is the only thing because as far as I could think, there were people who got calls from a lot of companies just because they had like research papers published out. So maybe building a profile is another thing that you could do.
Hmm.
But apart from that, I don't really think there is a magic solution that could be applied.
Okay.
And
Yeah.
so like in terms of gaining experience, as long as we are student, like we can do internships. So like what are the key differences of doing a research internship versus doing an industrial internship? What exactly does it stand, its value, and like what significance does it provide to the recruiters? What value does it stand for in your resume?
So that's something I'm not really quite sure because that's a good point that you brought up that the recruiters would be the first person who was seeing your profile, and they might not know that well about
In
about
terms
machine
of,
learning
yes,
or deep
yes.
learning stuff. They would not know those stuff in that much detail. So
Hmm.
uh, in that case, yes, I would say if you have a big name company, on your resume, it's a sure shot way of you getting an interview call
Mhm.
because it's much easier for them to filter based on that. And again, something similar would happen if you have been publishing papers in good research conferences. That is again something that's much easier to stand out. And in that case, I would say um, it's kind of hard for me because I don't really know how
So
recruiters
it's like,
recruiters are trained for this. Just to give you guys a heads up, recruiters are definitely trained to to spot machine learning candidates, but I'm not sure how
so
how they do
so like
really do that.
if I were to weigh research versus industry experience, there's not a clear standard that recruiters even would have, according to you. Do they value a student more who has much more, say, research work done, published, or research projects done, versus a person who has a maybe an average industry experience working in your case it was eCrypt, like you worked on data science projects over there. So like, would they prefer more the industrial one or the research one for the machine learning tasks? Like, in your reference, I would say Google. What could be an ideal
So I guess
scenario?
both. I would say both are equally valuable. Doing research or to having machine or having industry experience.
Mhm.
Industry experience, I guess, just makes you more flexible because industry experience means you have like software development experience as well along
Right.
with it. So it just makes you more flexible. But specifically to like uh, like machine learning roles, I guess both are equally,
Mhm.
if not so. Like I would say research is a bit better thing because you like the internships that you would mostly do at any of the big companies if you're doing it machine learning. It's not gonna be you won't be building some software development. You would be running some sort of experiment or trying out something new that a team thought, let's see if it works. So that's the kind of thing you would be doing in machine learning if you're interning at any of the big companies.
Right. 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 And yeah, Omkar, do you have some?
Uh, Not really. Yeah, just one question was just a minute. Yeah, so what do you think about the future in machine learning? Which areas would assume more importance? Like, for example, the computer vision field seems to have saturated in terms of research, and more opportunities are available in the applications of it. So, whereas NLP is still a trending topic. Do you have any such like ideas to share?
So I would say to be the same. Like, yeah, vision is kind of saturated, and it's more towards like commoditizing it and like productionizing it and pushing more products out and out. So you will see a lot more thing happening with vision. And the second most thing popular is NLP. GANs are another something that is pretty popular right now, and also reinforcement learning. They're pretty popular. Pretty, and I guess GANs are kind of being like GANs are something that could be used in a lot of different spaces in a lot of different ways. So
Mhm.
that's again something that is picking up in at least in research. Apart from GANs, RL, um, I don't really
Unsupervised
think. Yeah,
learning. Uh,
Unsupervised, yes.
yeah.
yeah, unsupervised. That's unsupervised learning. So GANs are sort of like GANs autoencoders, like all fall
They
into that
overlap,
sort of
yes, they overlap a lot in between, yes.
overlap a lot. Yeah, unsupervised learning. Yes, in terms of I guess industry, unsupervised learning is kind of important because you're scaling out. You cannot have humans collect that much data for
Yeah.
building these massive models. You cannot spend that much effort on that. So unsupervised is definitely on that, but I'm not really sure if there is any new domain, like new, totally new field being researched just for unsupervised. I guess it's just iteration on the older. A lot of things is just iteration on the older things, but yeah, it's just iterations going on over the older stuff. Like, can you use clustering? Can we use some sort of pre-signals that we already have on the data to kind of make our life easier? But that is, I'm not sure if that's really qualifies as research or more of an engineering opportunity.
Okay.
Right. And
And yeah.
and also, like you mentioned, you work on many of the computer vision and perception projects. So how do you keep yourself updated to some of the latest outbursts in terms of research, or in any kind of like you mentioned, computer vision is being much more saturated and much more work is done in the production. So like how do you keep updated, keep yourself updated to those things? Do you read papers from some specific authors or conference, or do you follow any blogs or website? How can one make sure that they are updated to the latest developments in these domains?
So I actually don't do any like I don't follow as such any like blogs, authors, or anything of that sort. Um, right now, the all the things that I do know is like internally at least at Google, you have research people. Like someone in my team will say, okay, here are some papers we should read,
Right.
or in a general bigger group, someone will just say, okay, this is something like I went to this conference. Here is a summary of that conference. So things like that are keeping me updated right now. Prior to that, it was all about me trying to just look up stuff. Like on Medium, you could just find like what's the things that are going on in machine learning, what kind of articles. Because at least for me, um, I would say like it's because I was not working in any sort of research firm, so research group. So I didn't have any like real push behind to kind of jump into and read some you know new research papers. But yeah, if I saw something that is kind of related to my work, there is a blog post about it, then I would just go and read a blog post, or just keep up to date with like what like Google has its research blog, Facebook has its research blog. If they are putting out some stuff, I
Hmm.
just read and just kind of just go through the summary of it just to see if it kind of aligns with what I'm doing right now.
Right.
And if yes, then I would just go and read that paper then.
Right. Right. Right.
Uh, yeah.
Yeah.
One question which I had was about the job role. So your role is software engineer, and Google and Facebook and many big companies have a research engineer role,
Hmm.
which is between a software engineer and a research scientist. I'm
Okay.
not sure. Yeah. So is there what is the difference between a like a research engineer and what you are doing as a software engineer?
So I guess there is just the level of research work that you would be doing. So as a software engineer, like you could be in like my team, we have like little bit of leeway of doing some sort of like novel ways of research sort of stuff. That if we could come up with some sets, let's say, like I said, new sort of like unsupervised way of training our models, that's allowed. But there would be other teams who won't be doing that, but rather they would just be, let's say, trying to move the threshold around to see better performances and stuff like that. And then you have towards the other side, like let's say one end of the spectrum is like you're doing in pure research thing, and one end of the spectrum is total pure engineer, pure software engineer. So it's just about moving the needle.
Right.
Um,
Okay. Hmm.
so yeah, I guess that's the major difference. Like if you maybe you are a research scientist at Vimo, you would be building you would be trying to see how more information you could get from the lidar sensors and stuff like that you have.
Right. So
Hmm.
it seems like some kind of production line where every person like is assigned different tasks within that supply line.
Yeah, it's just like I said, it's a spectrum. Where you put your needle over there is sort
Hmm.
of, I guess, the job definition. Mine is kind of is I do a lot of research. I don't do research work as such, say, but we do have to think about like how we could improve. And yeah, my team does put out papers, but it's mostly around how we could use our existing technologies on some other problem. That's all.
Right. Yeah, I guess that's all questions that we had as of now. Like, would you like to give some kind of general advice in general to any newbies in the field of machine learning? What exactly do you like? You see definitely this as at a much more bigger picture. You have
Mhm.
seen being working at machine learning, who leads those machine learning research. So, like, what piece of advice would you give to people who are starting off their career, say in terms of academia or industry? Any kind of advice applying to jobs, or say applying for PhD, masters, or whatever. Any piece of advices?
I would just say, like this is something I've like observed with people. Like it's machine learning is like a kind of like a shiny thing, so a lot of people are attracted towards it. But I would just say, do it in earnest. Like try to figure it out, because for a lot of people I've seen, they don't really like the data analysis part. because it's kind of muddy and there's no clear thing and things are not glorious. Like, right, if you figure out, oh, my data composition was wrong, that's not something that you could, tell on a PowerPoint presentation to your manager, look, this is what I did. Or
Yes.
just correcting it. It's not that glorious as well. So a lot of people don't like it. So I would say figure that out first, that did you really like machine learning or not? And after that, build up your base. And as for jobs, I really don't have, I don't really have any pointers what you could do. Because even for me, I would say it was like, for me, like I applied for Google, the usual way for software engineering new grad. I got rejected in December, but then a recruiter reached out to me in March saying that, would you like to apply for the same role, software engineering new grad? So I don't really have
Wow.
a pointer like what you could really do here.
Wow. Yeah, that's great. Yeah.
So that's good.
Yeah,
Yes,
it's
it's
weird.
like
I don't know.
the January to March was really lucky for you. Nice, nice. Yeah, that's all we have as of now for this episode. And like once again, thanks a lot for taking the time out on a Sunday evening for this. And
Yeah,
yeah,
thank you.
And
that's
no problem. Like, I guess like this is pretty cool. Like, especially if you are looking at people who are doing the
uh, the voice just cut off. Can you just repeat once?
Oh, I just said like it's pretty cool that like you guys are doing this because for people who are just starting out, it might just help them, understand what's really there. Like if their end goal is industry, like
Yes. Yeah,
yeah,
so like
what's
we plan to do these webinars much more, and we hopefully can invite more speakers for these kind of stuff to share their like experiences and information, because not a lot of help is directly available or explicitly available on the internet how they should move forward, and also the academia is not exactly very supporting for these factors. So like it kind of, like you said, it's a very muddy way. Like you said, like most of the people are just blinded by the shininess of this machine learning application. They seem like a black box on the top of the, like it's like a cherry on the cake and seems good, things seem good,
exactly? Yeah,
but it doesn't look like. So we just wanted to portray of how muddy can it get by the help of professionals like you who are willing to share those things. So yeah, it's like I hope hopefully people would have some great insights from this, and maybe they can share, like they can connect to you or in some way any other possible. And
sure. Yeah,
yeah,
definitely.
and yeah, thanks again, thanks Omkar, and thanks Shashank for joining on this call.
Cool.
Sure.
Thanks,
Yeah,
guys.
okay,
Bye.
have a good evening.
You too. Bye.
Bye.